What is up? What is up? Oh. Wow, there's a lot of people showing up fast. Where's there? It's Saturday, people. Why aren't you out at the beach or hang gliding or like climbing a mountain? It's Saturday. Oh, the G-Cores talk. Yeah, that was fun. I cannot find the teapot lid. This is an emergency. There it is. Okay, we have teapot lid. We have teapot lid. Yeah, the G-Cores guys are cool. You know, it's a couple years ago. Now I went to Beijing, and was it really a couple years ago? Yes. Wow, time flies. I went there and we hung out, and I did a talk at that conference, and we did a podcast. It was cool. Would a debug display that only showed the gameplay state help with debugging issues with the transaction system? Maybe, but I haven't been motivated to do that because I haven't really had a problem with that. If I want to know what the gameplay state was, there's a way, you might have seen this in the stream, but there's a way that I can open the editor and have it load the gameplay state. So I can see what it was if there's ever any question, and that's fine. You watched episode 6 and 7 of Westworld season 3, and now your day is ruined. I couldn't get past like episode 4. That show is over for me, man. I mean, my assumption, okay, this is not a spoiler because I don't know. But I think the whole season is happening in virtual reality, right? I think so. In order for the world planner sphere to plan the world, it has to have a simulation of the world, and I think they're in the simulation of the world that the world planner sphere is using to plan. And I think that's the shark they're going to jump at the end of the season. But it doesn't matter because it's so bad. Oh man. Is my Reese's Pieces, are they that loud? Yes. Yeah, it's just weird. Like, Westworld season 3 feels like a 1980s TV show. maybe 1990s. It's really weird. Not quite 80s. 80s is pushing it a bit far, but like I just don't understand. Well, what are we gonna do? We are gonna we're gonna replace some old things with some new things, and we're not gonna do anything new yet. We've been doing new stuff for the past few days. Now we're gonna do making the same compiler better stuff. We're not gonna take over the world. Not directly, anyway. You may succeed in the game industry. Yes. Okay. So, I mean, where do I put the new? Let's go to pipes. Pipes. Handling the run pipe. Okay. So, we're going to need to make a custom thing that goes here. Have I fixed the build server, or does it still randomly crash? The problem isn't really the build server as far as I can tell. The problem is just there's a race condition in the compiler that I'm pretty sure I know what it is. And it, let me try my tea here to make sure it's good. That's probably fine. And for some reason on the build server, this race condition gets triggered like 80% of the time. Whereas on every other machine, well, including when I run things manually on the build server, it almost never happens. So maybe there's something about like Windows process priorities when something is not an active, user input process. Like, I don't even know, but something like that is causing it to run really, really badly there. Now, what that means though is, so first of all, I should fix that race condition, which I'm working toward. The stuff that we're doing today is actually working toward that in a mildly indirect way. Secondly, though, it means that I should probably think about how to put more robust stuff in the compiler in order to detect that kind of thing without needing adverse operating system conditions. Like, if you have threads that are going to pick up some work to do it, you could have a flag that says, hey, everybody, randomly scramble what you pick up, or randomly just sleep 10 milliseconds before picking stuff up if you want, or whatever. And then we'll see if that helps detect things. That would be a good idea to do sooner than later. But wow, I just inhaled a peanut M&M the wrong way. If you want to succeed in the game industry, don't do that. No, sorry, that wasn't a peanut M&M. It was a Reese's Pieces. What am I talking about? What am I talking about? Okay. So what we're doing today is we're taking out the last vestiges of the way dependencies used to work in this system, and we're going to put in a new one, or we've already put in most of the new stuff. We're going to put in new stuff for the run pipe, and it's just going to be the same thing that happens with the old stuff, but different. And so how are we going to do this? We're going to go... So first of all, you have to have an expression to get... I don't know why I did that. Okay. So the two things we care about are lambda body and run directive. And I'm just leaving this here, even though it's not used. Okay. So what is directive runs deal equals, so we don't let the run through if the lambda body that it's waiting on is not ready. Otherwise, if it's a lambda body, then Well, we want the lambda body, and we want so I have a little snippet of code I want to paste and change. It's one of these. Okay. Instead of cues we need to build, we're going to say we'll say call these. Okay. Collies is a weird word. Okay. So now I have to make this array be a thing. Still got some cute in there. The cute is intentional. The cute is correct. Well, actually, yeah, the cute is correct. Great. Okay. So, so when was the last time I programmed in C, like not even C++? Well, I mean, I wrote a C backend for this compiler, and so I did some C at that point, but not a full program worth. I mean, I might be forgetting something, but I would guess that the last time I programmed in C it's probably around 1994. Like, were you even born that yet? I don't know. Those were wild times, 1994. Boy, I really messed this up. I wasn't even thinking. Why is Last of Us a bad game? I don't know. Why is it? You're the one who said that. Okay. So far, we'll just be able to run, and it's fine because we didn't actually put anything in this array that we just made. Can I get rid of this? I should be able to get rid of this. Like, does that screw us up in some way? You know what? It's been a little bit since we ran the debug compiler on the tests. Like, that's a little bit irresponsible. We could be asserting on some operator stuff that we did over the past couple days. So let's do that real quick. We're going to debug compile, which is slow, both of these. And just make sure that we're okay. And if that's okay, we're going to delete these lines of code here. And then we'll do a little check-in, just a little check-in. All right, let's see if the game runs. Do I think making a compiler is harder than making a legit kernel? I would say it's probably about the same. It depends on what you include in what that kernel is supposed to do, right? Like if you say like the file system has to be journaling or whatever, then that adds a lot. If you're not going to include the file system in the job, that subtracts a lot, you know? So you'd have to define. Do I think Last of Us is good? Well, I don't like that kind of game where the main thing is the story. I just don't enjoy those. So it's certainly not for me. Does that make it bad? Well, it's probably good at what it's trying to be. It's just what it's trying to be is not something that I like. Like Minix. I'm not familiar with, I know generally what Minix is, but I don't know what it contains. You know what I'm saying? Yeah, that's also someone in chat is saying what I think about it too, which is just these story-based games, the stories are not that good. They're just good compared to games. So like that's just like playing those because they have good stories is like it's like swimming in the kiddie pool and thinking you're a good swimmer. I mean, not a good analogy there, but you know what I mean? Like, look, I'm swimming better than all the people around me. And it's like, why don't you go into the actual swimmer pool? And it's like, but I'm in the kiddie pool. I'm only looking at things in the kiddie pool. Like, is a 4K monitor worth it for programming? I use a 4K monitor. Minix is 5,000 lines. Oh yeah, that's way easier then. Come on, bro. Who would I include in the foundation of people who can bring software back when civilization collapses? There are not very many. There are very few people so far that I know. That doesn't mean there aren't very many people. It just means I don't know most of them, actually. But yeah, most programmers are doing the wrong thing. Video games can tell stories at a lower budget than some other media like movies, I guess. Dude, books can tell stories at an extremely low budget. Have you ever seen the budget for a video game? It's very high. Books can tell stories for super cheap, and they're excellent at it, and they've been around for thousands of years. Why do you need a video game that's like a bazillion times more expensive than a book to do this? I mean, seriously. Do I have an intuitive understanding when I play a game of what is going on behind the scenes, how everything works under the hood? Yeah, probably. Like if you see a scene that's rendered, you kind of know. I mean, you might not know some specific things that they're doing, but you know basically how it works. And if like for gameplay logic and stuff, that stuff's simple. You could, I mean, you can look at a game. Okay, let me put it this way. There are some things that are probably not visible, like if you're going to talk about gameplay, like maybe the way the entities are set up, maybe you can't tell if it's a hierarchy or not, or if it's ECS or whatever, because that's invisible. But like, you certainly can look at it and say, yeah, I could sit down and program that in any of those ways that I would choose to, right? It's just not that hard once you've done it. So what programs do I use to modeling objects? I don't even know. I use Emacs to model objects. I use Emacs. Could I explain my philosophy of games? Do I think that games should not be entertainment? Well, look, people can get out of games whatever they want, okay? I think it's good for games to be many different things. It's not my job to say what games should be globally, because that doesn't make sense, okay? But if all games are just trying to be stupid wastes of time, then the game industry is missing out. I think the person meant 3D modeling. Oh, I see. I thought he meant like UML or something, right? Because that's called object modeling. If you meant 3D modeling, then so I don't do that, but the artists on the team use Maya or 3D Studio Max, and then we import it into the game. And then in our game engine, we have basic object manipulations like rotation, scaling, and stuff, but we don't actually do mesh modeling in the editor. Your friends are making a game in C# because of automatic serialization there is a main reason. Well, that is really not a good reason to pick a programming language, honestly. I mean, it's good. It's a helpful feature for sure, but it's not like you can't make that happen in C++. You just have to put in like a little bit of extra work. And so like, and the problem is, that let's say something saves you a week or two because you've never written serialization before and you get confused. I don't know, maybe for beginning programmers it takes a lot longer, but you have to weigh that against how long is the entire project going to be. And like how much does it save you on the scale of the whole project? You know what I'm saying? Like if it's going to take 3 years to make a game, 2 weeks is like not, 2 weeks of one person's time is not very much. Yeah, we export in our own format using like in Maya, you can run Python now, right? Something like that. How do I plan to use the compiler with new consoles? The problem is I cannot really talk about new consoles because it's very easy for me to break an NDA agreement that I have with Microsoft or Sony. So on this stream, I will not be able to discuss those issues, unfortunately. What software would I most like to see in the world that I am not working on? I mean, anything that actually works, honestly. Like I would, if somebody was making a reasonable operating system, I would use it. All right. Do I consider the Switch's OS reasonable? I have not really looked at it, honestly. I am not educated enough on this to answer that question, although I thought it was just an Android customization, isn't it? Isn't it like done by NVIDIA? Or does NVIDIA just do the graphics drivers? Does Last of Us bring any ideas through gameplay, or is it just entertainment? I mean, I didn't play Last of Us that much. I played the first game for like probably a little more than an hour, and I was like, yeah, I'm not into this. So I didn't play the whole game, so I can't tell you. Will fully implemented debug symbols on Windows and Linux ship with the compiler? You already have that. You already have that today. Have I seen Herb Sutter's talk about CPP simplification in future iterations? I have not seen that talk. I agree that this is necessary, but I also think C++ is unsavable. There's no point. Just give up on it. There's no point. It's much better to do something from scratch than to try to improve C++. They roll a full custom OS. Some parts are things you might find in Android, but you can't say anything more. Okay, yeah. I mean, I don't know anything about it. Now, the thing is, you know, it's still an OS for a device that is not trying to be a general purpose computer, right? When I said before, I would totally use an OS if someone was making it. I meant, of course, for a PC, or not a PC specifically, but hardware that I could like program on, you know, which is not, of course, not the Switch. But it's cool. I mean, you know, I think both Nintendo and Sony then are still making their own OS effectively. Microsoft kind of isn't. I mean, it's a Windows, right, that they run, but I kind of think it's not really that customized for the console anymore, which makes it different. thing with really hurts C++ is the build model, I think, yes. I mean, there's lots of problems with C++, but I would start with that one, yes. Because that's also the one that they're just not going to solve. Okay, what were we doing? We were seeing if all this passes. It did. Let's just delete these lines of code because we don't need them anymore. We're gonna build the game again real fast, quote unquote, just to make sure that shouldn't have done anything. And then we'll check this in, and then we'll continue. So like this is literally the only thing. That's great. Okay. So what we're going to do, this thing, which is part of the old system, we're going to replace this by putting something in that new known callees array, and that's going to totally break the compiler. And then we're going to have to like retool it to use the new thing. But then the point is we remove this dependency system completely. And then we get to delete a bunch of code after that. Like all this will go, a bunch of things will go away. Okay, so that compiled. Let's double check that it runs. It does. Okay. Commit prep for switchover of pipe run to new system. This is going to be a historic day. Let me tell you. The compiler has worked this way the whole time since it existed, and we're now about to remove this last piece of how it used to work. It's crazy. Actually, not really, because part of how it used to work is still how it works, but yeah. Once language is shippable, I'm going to make video written tutorials for it. I'm already sort of making written tutorials for it for the beta people, and I want to put more time into that. That's for sure. Do I find that writing tests for a compiler is more straightforward and simpler than doing so for a game? It is mostly, yes. It's a lot simpler. Games are just really complicated world state, and compilers just don't get that. Like the state of the program that you're, like the syntax tree of the program that you're trying to compile never really gets as complicated and weird as a game does. Games are harder in that dimension. Okay. Now, well, if we go back to this thing that I was just pointing out, this thing, so we're going to put there instead, we're gonna remove this. Okay, first of all, if we remove this, the whole code breaks. All right. Okay. Okay. Depending body. And then we're going to say known callee I don't remember if this is the right name for this function. I need to change it a bit. So the callee is there, and we say callee requester is call. Callee, what did we call it? Callee equals equals lambda body, like that. Okay, this, okay, what is the name of this function? Add and return pointer. Oh yeah. I'm getting mixed up between the things that we have. Okay, this is going to break things. Everything's going to be totally broken if I hit this right now. I should say circular dependencies or something. Or it just will infinite loop. Yeah, it's just infinite looping. Okay, the reason it's infinite looping is because we're frickin' rejecting everything. And this is going to be the not fun part. So now, like this thing here is rejecting stuff. Oh, we should do an official throwback. That might keep us from infinite looping. Whoops. Probably not. Nope. So this is going to be annoying to debug. I mean, not this yet, because we know what's wrong. I think. You know, this is a little, this is a little too restrictive right here. I think the problem is we're going to end up throwing back everybody. Nobody will ever pass this initially because we're not allowing anybody to. All right. Anyway, let's go look at the code that we have to replace. Where's detect a cycle happening? In pump, really? Okay. Okay. It's an expensive chair. Well, I sit in it like literally every day. So what, it's worth putting some money in. Okay. Wow, I was just looking at my screen and this piece here, it's still happening. There's some optical illusion happening in my brain where this big thing, it looks like it's slanted like upward on the screen at a weird angle just because of like where I'm looking and how my head is tilted or something. Like here it's not really feeling that way, but like here it's totally feeling that way. It's like it's crooked. All right. That's so weird. It's a weird shape. Okay, so here's what's going on. Let me explain what I'm trying to do. Is I'm trying to make a new system so that functions only pass this stage in the compiler pipeline when everybody they call has also passed the stage of the compiler pipeline. So leaf functions who call nobody should just go right through. The problem is, okay, if your program was a simple tree, then everybody would be able to go through and it would be fine. Problem is, many programs are not simple trees and they have cycles in them, right? So like you of course don't want to end up in a call cycle at runtime because you'll blow out your stack, right? You're just infinitely recursing. But it's certainly quite not only possible, but quite common to have a cycle that just never engages at runtime because it's like different if statements causing different things to happen, right? So actually also, let me check. So you also don't want to put a dependency on yourself. And here, let's go there again. And just make sure that we don't do that. Putting a dependency on yourself is silly. Okay, so we're just making sure we don't do that. I don't think that'll change anything. So the problem is, if all of these functions are ready to run, then you're okay, right? Now I'm trying to rethink through. So you kind of want something that goes through and searches for cycles in the graph of people waiting on other people to run and says, oh, all these guys are waiting on each other so they can all pass. Now, the reason I'm thinking through this and not just wanting to port over the old structure is because part of what I'm trying to do is make the compiler better. And I'm actually not sure. I'm actually not sure that anything happens in the run pipe anymore except that. I mean, run directives get put on a list somewhere, but lambdas don't get this far. So honestly, we don't need we need pipe index here. So suddenly, as soon as we do this, I don't think we need cycle detection anymore because run pipe doesn't do anything. It used to be that something happened in run pipe, so I don't know, maybe I'm being stupid and not thinking of something. But I think we're okay. That means we would get to delete even way more code. Oh my God. Now the problem there is that other people may be yielding on a different condition, like in let's just like if pipe run doesn't do anything, anymore, then maybe we don't need it. That would be great. But we're not going to try that yet. We're just going to try to get this system working just as is. Okay. So this isn't going to work, I assume. Yeah, it's just infinite looping somehow. Let's see if we can build a very simple program we were doing yesterday. Nope. So, well, let's just see what it looks like. Oh, we're in the wrong file. This one. So we're just going to start this and let it run for a second, and then we're going to break there. No, we're not even here. Well, somehow we're putting 100 million items in the run pipe. This throwback isn't... Can I not do that? What? I'm confused. I thought I could just do throwback. Let me look at what I do. It might be that I'm not allowed to do that directly. Like sometimes I set this must throw back or should throw back. This one's a little different because it takes a job structure, so let's not look at that one. Oh, we have to remove it from output. That's the part that I forgot. I don't know why we have to do that. I guess the pipe doesn't ever reset its own output. So here, though, here we're not removing from output. This is like when you forget how your own thing works. Like this could just be incorrect and causing a problem. So that never throws back. This throws back. And it doesn't remove from output. So throwback adds to input. Okay, when we pump the pipe, we reset output. So that's fine. And throwback adds to input, so that's fine. Now, it is the case that when we want to thread this, we don't want to be hammering on the mutex anyway, so we want to put these somewhere locally, but I want to figure out what's actually wrong. Oh God, we're continuing the wrong loop in here. That's what's wrong. C++ doesn't give us, it's got all these advanced features, but I can't do what I want to do here without doing some crazy mega template scenario. See, I want to continue this out here. Casey and me working concurrently. That proves to you that we are not the same person. If you ever had that question. Okay, now we get the program contains circular dependencies, which is better than infinite looping, in my opinion. There we go. That is better. So now, I guess I want to look at the circular dependencies and figure out So one thing we need to do is we need to actually report this better for when somebody actually makes a cycle. Time to rip out the pages from my notebook and go to a new page. This notebook has served me well, but we're getting close to the end. Okay. Better report circular calls well. Why not go to? Because Dijkstra would yell at me. Okay. So I actually just don't use GoTo that much. In this kind of case, I prefer not to. Okay. And the thing is, like I said, when we thread this later, we're going to want to limit access to this pipe. So we're going to want to put these in a temporary array anyway. Although maybe you could still do that with GoTo. I don't know, man. Okay. Got all these old breakpoints that we don't want. There we go. All right, this is the infer pipe. Okay, hold on. Let's just look at. Let's look at the situation here. Wow. This is weird. So I was expecting to see. So this is 0 doesn't do anything. This is infer, build, send message, receive message. No, sorry, infer, send message, receive message, build, run. This is the run pipe. Okay. So you have 19 things in the run pipe, and the infer pipe has some guys that are probably waiting on the guys in the run pipe. So let's look at the guys in the run pipe. And what their deal is. I'm having trouble eating these today. Yeah, my sadness right now is I put that array on the Lambda body. That means I have to cast to see it like every freaking time. Okay, who are we looking at? Line 409 of basic module. But that's cool. We successfully compiled the preload, which is great. New array. Okay, this probably is a genuine cycle. Like new arrays calling alloc. Alloc is calling assert. This will give you an example if you wanted to know. So here's the thing. This is calling alloc. Alloc is calling allocator, although that's not a known. it's not a known callee because it's a runtime function pointer. So actually, I was assuming that this was going to log or something, but it doesn't. So let's look at that. So our known callee's cursor is 1. So the callee is line 48, which is probably our alloc, right? 48, yep. Okay, what is this guy's deal? So, oh, he's waiting on usings. This guy isn't. Wait, no, he's not. Okay, this guy, okay. This guy passed pipe run. As you would expect. He has no callees. Okay, so this cursor is done. No known callees. So why? That seems easy. Like, why did we not? Why did we not deal? Okay, well, to answer that question, we're just going to go back to where we were, and we're going to say it expression s is this, and we're going to like skip the first couple times because, you know, legit it might not pass. Oh, it only goes twice. 1, 2, let me F5 one more time and it'll die, right? Bam. Okay. That doesn't seem right. That does not seem legit. Like, so when we decide that we have a problem is when we run through these pipes and the pipes can't make progress anymore. And well, I mean, I guess we got a ton of stuff already. I guess we skipped most of the actual cycles. So this actually looks correct. There's just 19 guys. A lot of things passed through, which you can tell because we expanded our array up to 4096. What's our output queues? 3799 procedures compiled, so that's pretty good. Let's just see. So this is going to be probably alloc, right? Oh wait, no, because our cursor, yeah, this should be alloc again. No. Oh, we're in the preload. Wait, what? Did I look at it wrong before? What is happening? Okay. Okay, hold on. Hold on. Who are we looking at here? Line 409. Isn't that the same thing? Okay. Oh, okay. Guys, here's the problem. Alec was element 0 of that array, and I was confused because I was like, it passed. No, that's fine. I just looked at the wrong element in the debugger, right? It's memset that we're waiting on. Now, the problem, ladies and gentlemen, is memset is an intrinsic. It's not, it doesn't have like a body that's going through the pipeline. So press 1 if you're a lady. Look, there's ladies in this stream. They've said things before. Thanks for the free sub. Yeah, I'm happy to support other streamers. How is memset implemented? Well, that depends on which backend you're talking about. So the answer is a little bit indeterminate. But the point is, it's not a procedure that you call that's in the programming language itself. And so this is just getting confused by that. Time to open the window again because I'm drinking hot tea in a warm room. Okay. So, memset. What is our best solution? We could just flag all intrinsics as, I mean, we could exclude them from the check at this point. Okay, this is going to dovetail into something later, where we generate so-called lambda bodies for all things that are procedure-like, including intrinsics and foreign procedures and just function pointers, and we probably don't want to do that eventually, which means we would not even be able to, for something like an intrinsic, we would not even be able to do this right here because it wouldn't be there, but we would know, we would look and say, oh, there's no body. Okay. Anyway, though, so this is the problem. So need.callee that's why it's in preload. It's in line 409 of preload. It's just verify our thesis. Yeah, memset. Let's look at that. Ask lambda body need.callee. Not bloody, bloaty. Bloaty. It's just a lambda bloaty. Okay. Oh God. This is also wrong. This checking pipe index is wrong. Because pipe none, maybe I should change that. Okay. We're going to do this. That is just not the right thing. All right. There we go. Okay. So we're getting circular dependencies in Sokoban. Okay. Okay. Well, this is our smaller program, and this seems bad. Seems like we're not letting things through the run pipe or something. So what's my theory about this? Why not generate already the bytecode of the intrinsics before the compilation starts? The intrinsics don't have bytecode. That's not a thing. Okay, so we're just not letting stuff through for some reason. And I mean, except it's like literally no procedure is happening. This is very weird. Let's just stop here. And we're going to look at the pipes again. Pipe run has 54 things in its output still. However, we're deciding to finish compilation without erroring. So does that mean that these all passed? Yeah, it says pipe index 0. Well, let's look at infer. Infer is clear. That's good. So like, I mean, what happened is my question. Like we just stopped early. Let me try with the x64 backend just to see if this is something weird. Okay, I can work with this. I can work with this. That'll tell me which procedure is having a problem, and then we can follow that. So this assertion that's going off is saying, hey, we're trying to output information about a procedure, but the offset within text section is -1, and what that means is the code hasn't been generated for this, and you're trying to get me to set the pointer to the code, and it's not there, and why? Okay, so what is the lambda? It's line 248 of array. That's polymorphic. Oh God. Are we? Hold on. No. Okay. So this is an instantiation of a polymorphic procedure. So 64, 16, 32, 48, 64 is lambda. Okay, that's fine. This is an instantiation of a polymorphic procedure. Let's see where its body is. It's still in the run pipe. Okay. So yeah, we still have guys in the run pipe, except we don't. Okay, we're going to manually remove dudes from the output when we handle them, like that one thing was doing. Okay, run pipe. We're going to put this in there. And we're going to say, not necessary, but helps us debug, exclamation point. Okay. Now, I don't think this is actually going to help, because then we would see these guys in the input array. So, like, I almost don't really know what could possibly be happening unless this is happening. But then we wouldn't be going into compile, right? Let's just see, did we report error? Interp reported error. False. This doesn't need to be there anyway because the run pipe doesn't do anything anymore, like we said. Maybe print out pipes for debugging, maybe. I've gone through several iterations of doing that in the past, and it's just confusing. I definitely should do that in some way, but I don't know. It's just confusing. Like, this should be pretty simple. Like, the problem right now is I don't understand. It's going to be something super simple. Let's actually even collapse this. So this is all run directive stuff. We don't need to assert this. Okay. We already have the, yeah, like, great. Great. So this is run directive stuff. This is Lambda body stuff. Either way, if we were in the output, we should either get thrown back. Well, for run directives, it doesn't matter. Let's just look at Lambda body because that's what we're having a weird time with. we set should throw back and break, right? So we throw back. I feel like this is screwing me up somehow. Like I did something dumb here. How does collies.items decrease? It does not. What happens is this gets to the end. I could decrease it by removing items from it, but I'm leaving them around for debugging purposes so I can look at the array later and see what the hassle is. But yeah, it never decreases. Well, since we know a procedure that seems to be slipping through the cracks, again, we can just set a breakpoint and see what happens with it. All right. Now its yielded on expression is set, which we don't ever reset that, but that might be a clue. It might be a clue that we got here. But if we did throwback, it would be in the pipes input, dude. And there's nothing in the input. There is nothing in the, okay. So at this point, let's just, oh, I forgot to, whoops. Right, we can't do this in this, okay. Okay. Wrong macros. All right, so we'll run this. It'll do the same thing probably. Let's at least find out. Okay, do we have the same guy? Line 248 of array, that sounds the same. Yep. So, what does that mean? In terms of this, so the lambda's queued. Oh, you know what this is? Actually, I don't know what this is. Okay. The body is not, it's stuck on a known callee. This never happened. All right, well, let's see. This is one of these things. Okay, I can already feel today I'm at like about a 50% brain power day, which is not that bad. Like you can get a lot done in a 50% brain power day, but I can already tell this is taking me longer to figure out than it should. This is something really simple. I think this is not like a crazy problem. Okay, so we set the yielded on expression. We should throw back. We do throw back. What does the pipe's input look like? Input has an item in it. Okay, next time. We say, we yield on it again. We set should throw back. We do throw back. Okay, it's got one item in it. Okay, same. Should throw back. We do throw back. It's got one item in it. I mean, oh. I know what's going on. So what's going to happen is we're going to call report circular dependencies. Okay. Here's what's going on, guys. We do still have a circular dependency somehow that we probably shouldn't have, but might be legit, okay? When the compiler gets stuck, it calls report circular dependencies or whatever that checks to see if there's a circular dependency, right? Now, the problem is we're doing this check that I just added in a different place than the old system did. We're doing this down here, and the old system did it in pump pipe and wouldn't let things go into the output. Now, the way report circular dependencies knows if there was a circular dependency is if nothing went into the output. But we're letting everything go into the output and then post rejecting it. So we're not letting part of the system operate as designed. And therefore, press F to pay respects. Okay, now see, I turned on. I just had to turn on part of my brain and stop, because it could have taken me like 2 more hours of plodding through this kind of debugging, because it's a big system. There's a lot going on. I feel like the majority of our streaming audience does not have respect. You don't understand, but F, okay, good. OXF, okay. That's the programmer version. So the F thing, I will explain for people who don't understand. It's really ridiculous. So one of these Call of Duty games from way back, there was this really touching cutscene, supposedly. With Kevin Spacey, I guess. And like, it's supposed to be this super touching thing, but like, it's just very video gamey and weird. Like, why is like it like shatters? Wow, that's an awful motion blur. It just like shatters the gravity of the moment to be like control prompt, right? And so that sort of was a meme for a while. And then on Twitch, it just took a second life of its own. Look at that motion blur. That's terrible. Why does anybody like motion blur? It's just awful. Don't put motion blur in your rendering engine unless you want to be Call of Duty and make trillions of dollars. Yeah, like the people who put that prompt in didn't even think about it. They were like, what? You want to be able to do this in-game action, so let's hook it up. But it's like, it's just so silly. All right. And then that's where F comes from. The game just waits until you press it. Oh yeah, that makes it worse for sure. I mean, there's all sorts of things that make it bad. Okay. Why are you adding Handmade Hero here? Casey's probably on his own stream. Casey's not here. Can you insert members into already existing structs? No. The reason for that is that part of your program may have already compiled to use the old struct, and you would get an inconsistent program, which you don't want. All right, so I'm not sure what the best way is to do this in the long term. I mean, I sort of am. But let's just preserve this. Let's preserve this. So this whole thing is going to go elsewhere. It's going to go into pump pipe. All right. So I don't even remember what cleaning dependencies is for. We're not even going to do that for now. Okay, so we're just going to do a totally different thing depending on what pipe we're in. If it's the run pipe, we're going to do one thing. Otherwise, we're going to do another thing. And this other thing, this is fine, because this other thing actually doesn't happen anymore, and we're going to delete it. But we're going to delete it once our program is working and we're in the clear. We're going to have a code deletion festival. Okay, so we're going to copy this part at the end. And instead of throwing back, we're just going to continue. Because you don't throw back from here. This is the thing that... All right. So I guess we remove from the local input So the reason local input is a thing is because we don't want to hold a mutex while we do all this. So we copy the things we're going to process. Then we process them asynchronously, and then anyone who's left goes back. Oh, this guy is removing because he's sleep yielding. Ah, okay. We don't do that. We just leave it. We're not sleeping anybody right now. Even though maybe we should, we're not. So we throw back. We throw down. We also throw back. Okay. We need our outer loop. Like, it's not a thing if we don't have an outer loop. Okay, and then we do our restoral. I mean, maybe this is the right thing. Oh. Still gonna fail to compile probably. Oh, interesting. We're back to infinite loop land. Why is that? Let's actually get rid of this, and we'll just say, if your cursor didn't get to the end, we continue. This is still going to infinite loop for some reason, but yeah, all right, let's see what happens. How much of the language is finished in terms of percentage? Minus 243.87 I minus epsilon. We're in detect a cycle. Okay. Because cycle detection, we should turn that off. Okay, so we have 41 things in the input. And they're waiting on stuff earlier, probably. So let's look. At least we're not proceeding to compile the program. That's good. What is bad is we're not noticing that this is like a circular dependency in some way. I don't know why. Probably because our circular dependency detector is making assumptions again. Okay. So this is in pipe infer. It's line 207 of array. Okay. Why is this stalled in pipe infer? Normal reasons why I would think that it might be stalled in pipe infer would be like it's waiting on a run directive or something, but there are no run directives here. It's just kind of straight. I mean, it's polymorphic, which is always hairy, but okay, so. So, like, what can we tell something else from this? Okay, it's stalled here. What just happened? God damn it. Like that? Like, why does it give that error message? It's the worst error message. Okay. Context. Okay, if the context doesn't successfully compile, your program is hosed. And let's see. Wait, what? Context is not compiling. Well, that's an issue. Where do we do this? Okay. Whoa, okay. When desk context gets past pipe size, which is, I guess, fine. We shouldn't do this here. We should do it elsewhere, but that's fine. So that never happened. This is in the infer pipe. It's probably waiting on context base, if I were to guess, although maybe not. So infer pipe, no flattened, not sleeping on anything. Oh, it's probably got do not infer yet set. Flag 64. Do not infer yet 64. Okay, right. So do not infer yet gets turned off here. In finalized context, that's what I was trying to look for before, and I couldn't remember what it was called. Finalized context. How do we get there? When we advance phase. So we broke phase advancement somehow. Oops. See, who calls this? I haven't looked at this in a while. So basically, phase advancement is like, look, you might add more stuff to compile at any time. As soon as you're not adding more stuff to compile, then we can do things like decide what's in the context. And then after we've passed that point, you can't add new stuff to the context. Because again, you'd be changing a struct that part of your program is using. This is like ordered and controlled way of doing all this stuff. Do we have trolls? All right. Let me get some more tea. I'm honestly close to banning Insobot again. Insobot is just on 20-minute pause. Great. All right, we are in sub-only chat mode. Sorry about that. Twitch doesn't seem to... Twitch doesn't seem to handle these things very well. Actually, we could put it in follower mode for like... let's say follower 10 minutes. And if we get another assault in 10 minutes, we'll just turn it to sub only. They all followed? All right. Well, At 1 p.m. we'll go back into sub-only mode. Actually, let's make it followers only for one day. Sorry. Eh. 1 hour? Like 1 hour. What about Insobot? Insobot can go jump off a cliff. I'm tired of it. If you have a game where players host servers and others want to connect to them, wouldn't things like open ports and some stupid available IP stuff be in their way, making it very uncomfortable? So, yeah, that's really annoying and stupid because people's home routers will tend to block ports and all that. Like, what you tend to do is have a, so a player is able to get to the central server in some way via some slow method, like, maybe it's even a web server or something. And you can use that to like do NAT punch through, like basically search for NAT punch through is the phrase that you want. And then that's the things that people do. It's annoying and stupid. Where were we in the code? We were figuring out why the context does not compile now. And it's because we're probably not ever calling this. It's probably this. Or wait, no. It's probably not that. Maybe it is. I don't think this should be necessary right now, but I might not be thinking of something. That's as I would expect. So we're calling, oh, wait, what? That's not what I would think. This is doing like a graph algorithm. Do we get there? Like we'd have to, right? Like what? Oh. Ha ha, okay. This is going haywire. This is operating on these dependencies that don't even exist anymore. So that's not really helpful. I think we just want to disable this because it's always saying every cycle like, oh yeah, I totally made something happen. And therefore we never, hey look, our compile program runs. Wait, our non-constant shifts? What? How did we break our non-constant shifts? Is that x64 backend? What's going on? What? Okay. We're going to have to debug this later. I thought we tested all this last night. We got an answer wrong in our non-constant shifts. Except this is the same couple simple lines that we were testing last night. This is the same test. Either I didn't notice that it failed, or we broke something since then, which seems unlikely, or maybe I just didn't run the x64 backend correctly. Oh, or, because remember we copied this to an official test. Maybe we fixed something in the test? No, because then it would fail everywhere. I don't know. We're going to have to look at that, but not yet, because we want to know if everything else compiles. Okay. Cool shirt. Yes, I know. It's such a cool shirt. All right. Let's do tests. Honestly, that wasn't... Okay. I was going to say that wasn't that bad, but now we have a problem. I was over ambitious. But that's good. I mean, we can compile the entire game. And that game does some crazy stuff. So I don't think we're that far from this being done, honestly. Thought we tested only the Cafe Babe. No, we ran that whole same program that I just ran. I mean, unless I'm hallucinating. Do I like fighting games? Not really. Not really. Okay, circular dependencies. Now what do our pipes look like? Did you see how long that took just to switch panels? This program is so bad. All right. We have two things in the run pipe. we have some stuff sleeping in the infer pipe. Let me guess if it's the context. Maybe not. Maybe not. Nope. Context is fine. That's good news. So we have some things that are waiting around for some reason in the infer pipe. But they're in output. Why are we here? Oh, because it says num thrown back 5. So things are getting thrown back in the infer pipe. Possibly because things aren't passing the run pipe. Okay, are these procedures or are these... I assume these are actually run directives. Let's see. No, it's a lambda. Okay, who's hanging out in the run pipe? Line 236. Temporary allocator. All right. Well, that does call a couple of things. It calls add new page. It calls max, which is polymorphic, sadly. It calls memcopy, which is an intrinsic. So there's several things that could be weird. Let's see. See, I don't even know if this is the problem or the infer pipe stuff is the problem. I assume in the infer pipe there's some stuff waiting on run directives that are waiting on this. Because temporary allocator, dude, a lot of people use that. Okay. Known callee cursor 4. Okay, so data sub 0. That's a lambda at line 471. I mean, it should be the one that's lexically first. So it should be add new page. Let's see, line 471. Add new page. Yep. Okay. Now we're getting spicy. We have an assert, which is a run directive internally, compile time assert. Am I recording only highlights of the coding projects or the whole thing? No, I only stream sometimes, but I program a lot of the time. So you kind of just only see, it's not like Handmade Hero where I'm doing everything on stream, if that's what you're asking, right? It's just, I do stuff on stream sometimes. Okay, so this is a little bit spicy. I'm not sure that that's related to the problem. I would actually guess that it's like this one. Let's just see who this is waiting on. No known callees. What? We must be early in the pipeline. Pipe infer. Okay, so this procedure is stuck in infer. It is probably in infer waiting on this. Why would it be waiting on that? Because the struct temporary storage is not done for some reason. Maybe. Let me see. Do we store that somewhere? I guess not. Let's look. It's an infer pipe. Cursor 7. God, this program sucks. All right. That data 7. All right. So, yeah, it's waiting on the run directive, which is that assert. Except that run directive completed. So why is it waiting? Let's take a look at this again. So if this is a run directive, then should have a substitution in all this. Okay. So we casted it correctly. Well, substitution. There is no substitution. That's weird. Is an assertion true? Oh, because it's an assertion, there may not be a substitution. Okay, wait. Is this... Okay. We may have a situation here. We may have a situation here. This could be a scenario where one of the known problems in the compiler that has not in reality been a practical problem yet has just become a practical problem. And that has to do with run directives and when they're allowed to run. I was not banking on having to deal with this today. So we'll see. Fortunately, it occurs to me that in this specific case, it's pretty easy to know what to do. But yeah, let's look. So the first run directive in the queue that would like to run is this the same one, line 472? Okay, this is the first one in the queue, which is better than I thought. So why don't we do that? Okay, no, that's not the right thing. Oh, we pop off the end. Oh, and okay, there's a stalled thing. Let's see. Do we have a stalled? Yep. Okay. This is a situation where do we store stalls? Okay, this run directive is line 462 of tests. Okay, it's running this thing. No surprise that that would stall. No no big surprise. How do I don't remember how to know what it stalled on. Stalled on Lambda. There we go. What you stalled on, bro? Line 169 of tests. Handle command line arguments. Okay. This shouldn't stall unless we messed up. So the thing is, you only really should stall if you're calling through a function pointer. Oh, wait. I think stalled on this means this actual thing isn't compiled. Right? Let's check it. Check the body. Check the body. Body. Okay, it's waiting on using. So this is going to be in pipe infer. Where are the usings? Why is this waiting on usings? I don't see any. It says right there, usings we need to build. Line 907 of compiler. Compiler get command line arguments. Okay, but why? What? What? Was ist das? That's the requester. Here's the using. Line 92. Oh. This is getting to be a very deep rabbit hole very fast. So our import of compiler didn't complete. I mean, dude, at this point, who even knows? At this point, you give up and you stop programming and you go play video games, but we're not going to do that. Benchmarking, no. I don't want to hear about benchmarking. It's not the stage of the project that we are in. Benchmarks are stupid anyway. Like, they're just gamed. You know, what matters is actual programs that you want to run and not things that are targets that people are optimizing for in order to juke the stats, right? Because anyone can juke stats. What's hard is to make something that lets you write programs that are fast generally. Okay. So I guess I'll keep tracing this a little bit to figure out why compiler is not compiling. I would expect that it should be fine. So here's the thing. Sokoban game imports compiler and it imports it fine. So my personal feeling is that this is in fact, okay. This is like a run directive deadlock. And actually we already know. We already know that this isn't going to install until like, which run directive were we looking at a minute ago? This one. Like, okay, let me explain the problem in detail. Why, for example, were we even doing the thing that I was doing? Where we're not letting things go through the run pipe and till other things go through the run pipe. It's because you mostly want to know statically what the call graphs of your functions are. Why do you want to know that? Because if you're going to run a run directive, you want to know that it's probably not going to stall for a while, if ever. Why do you want to know that? Because you can't really, if your story is that people can run arbitrary code in their program, right? Well, that code can be using global variables. It could be using state in DLLs that you loaded. It could be using all kinds of things, right? So the problem is you can't pause something like that and then run other run directives that may be running the same, modifying the same global state and everything, and then resume it. Because then you start having the same kind of problems that you have with multi-threading. It's like somebody's just trying to run their run directive and they don't realize it's multi-threaded with regard to like everything, and there's nothing they could possibly do to make it correct. So that's a disaster. So you don't want to allow that. Actually, you know what? I'm going to stop. See, this is where I have to stop explaining this because of my policy about not giving out the information that, yeah, I would like to explain this the rest of the way. I'm, however, not going to in fitting with the new policy. But the point is that run directives can get stuck waiting for other run directives to run. And part of that may be a bug in us not realizing that a call graph, it could be due to us letting things pass the run pipe too soon, or it could be for other reasons that I will not explain that have other solutions that I will not explain. Yeah, I'm sorry. You know, again, maybe my mood will change on these things, but anyway. Are we going to put the website up soon? I don't know, man. Okay, the point being, I actually think that the most probable cause of this is that we're letting things through the run pipe. That new thing that I did is letting things through the run pipe that shouldn't get through. I'm not sure why that would be. But we'll see. So what we can do is so first of all, I guess we're set up to run test already, right? Yeah. So when we're going to yield, or what do we call it in this case? It's should be called yielding, but we were already called yielding. So stalled. When we stall, let's see why we stalled. And whether it's for a good reason. Okay, we already frickin' stalled. So we're trying to call a procedure. Where are we? We are line 169 of tests, right? That's probably one of the things we were just looking at. Yeah, we're in handle command line arguments. Okay, and, or no, we're trying to call handle command line arguments, sorry. And it is not ready. Now the problem is this, it's right there, it's the first function. This should be a known callee. And we shouldn't have passed unless it passed. So what is the deal with this thing? Why did we pass? Actually, I was looking at the wrong thing. This is the header. Again, we need to look at the body. Here's the body. Okay. The body's in pipe infer. So again, it didn't pass. But that also means that we shouldn't have passed because we came from here, right? It's the only place it calls this. We came from build. Very first function call. This should be in our known callees array that we just had. Because it's there, we shouldn't go anywhere, right? So let me look at where we are right now. So this is thread. Call record stack dot data. Comma 2, because we want the last item in the stack. Okay, this is where we are. This should be build, right? Line 245. Line 245, okay. So, body, bam, okay. Known callees, 36, known callees, cursor, 0. This guy hasn't passed pipe run. Oh, did I mess? Oh, God, I made a tiny... Okay, remember when I changed this to pipe? Wait, this is the wrong one. Remember when I changed that to pipe build? This shouldn't be pipe, this should be pipe run. This was an epic fail on my part. Tiny, tiny mistake that cost lives. That's how you debug, okay? You don't plod through in the debugger until you see exactly the tiny thing that goes wrong. You do it till you get a picture of the situation and use that picture of the situation combined with your knowledge of what you're trying to do and the knowledge of the system as a whole to jump to conclusions, right? You want to jump to conclusions. Sometimes the conclusions you jump to are wrong, but there's a tutorial about this that we will now watch.
You know, there are people in this world that don't have to put up with all this shit. Like that guy that invented the pet rock. You see, that's what you have to do. You have to use your mind. Come up with some really great idea like that, and you can make it.
No sound. Okay, hold on. Hold on, no sound. Wait, really none?
Millions, never had.
Double sound. You hear it fine. Okay, we're going to do it over. I turn the volume up, turning my mic off.
You know, there are people in this world that don't have to put up with all this shit. Like that guy that invented the pet rock. You see, that's what you have to do. You have to use your mind and come up with some really great idea like that, and you can make millions, never have to work again.
You think the pet rock was a really great idea?
Sure it was. The guy made $1 million. You know, I had an idea like that once, a long time ago.
Really? What was it, Tom?
Well, all right. It was a jump to conclusions mat. You see, it would be this mat that you would put on the floor and would have different conclusions written on it that you could jump to.
That is the worst idea I've ever heard in my life, Tom.
Yes, it's horrible, this idea.
Now you know about jumping to conclusions. That is why you should have, I bet somebody is selling a jump to conclusions mat on the internet. Like, that's got to be, okay, look, people. What, come on. Like, you can get a jump to conclusions mat. Doesn't this look great? PC load letter. Right. Okay, PC load letter. Oh wait, this already compiled before. Okay, we didn't actually solve the problem. Sorry, I ran this and I was so happy because that was what was in my scroll back, but it was this that was the problem. So we actually jumped too far. That said, I suspect we actually solved something because this was wrong here. So I suspect we solved one thing, but there are more things. Let's make sure, though, that we didn't introduce new problems. Like, let's make sure that still compiles. Let me just, to keep morale up, let's just see that the game runs and how great it is. I mean, it's debug build, so it takes a while to load, but like, look, man, my guy goes. Just this game, we did everything down to the machine language instructions right now. That's how much for everything here. Every single thing. We wrote the engine, we built the programming language, we did the machine language instructions that are running right now. Never mind, there's also an LLVM backend. What's going on with turning? Turning is kind of gimpy right now. I don't understand. Anyway, I think we broke something in animation. Whoa, he just did a sick 360. I'm not updated with the latest data because I've been doing big changes, so that might be fixed. I don't know. So yeah, this all still compiles, and so we just have to figure out what's going on with this other thing. We're going to run again. Let's see if we stall. We do stall. Same place. Um, same call stack. So maybe we didn't really fix anything with that. Let me see. So this is tests, line 245, which again is here. So here's the deal, though. We're not supposed to run this until this passes the run pipe, until the body passes the run pipe. Let's go back. This thing right here is saying if a lambda's body has not exited the run pipe, then this run directive cannot go, okay? Now this, how does this get run? It gets run by this run directive, whoops. I thought it was at the end of the file. This run directive right here, okay? This run directive should not fire until its body passes the run pipe, which should not fire until build passes the run pipe, which should not happen until handle command line arguments passes the run pipe. Now, for some reason, one of the links in that chain is not being maintained because I made a mistake. So see, this thing has known callees that it hasn't even gotten through. And it's in pipe run. So like what? Okay. Here's what we're going to do is we're going to say, well, let's look at the run. So this lambda should be the body of that run directive, which just has a procedure call in it. So let's look at this and see where it is. Body. Okay, this one passed the run pipe for some reason. Okay, guys. Remember when I said we can change this to pipe build because pipe run doesn't do anything? And I don't remember why that would be wrong. It's wrong. It's wrong. So we need to do a substantial amount more work. So the reason it's wrong, and this is good, like this took like an hour to figure this out and whatever. It's kind of a waste of time, but it kind of rebuilds my understanding of the situation. If I just wait for something to pass the build pipe, that just means its own bytecode is ready. That doesn't give me the power to recursively wait. What this stage does gives us the power to recursively wait on other procedures. So we don't want to exit here unless otherwise it does not do anything. Okay, so this is fine. That's so weird that the whole Sokoban game compiled without this. That's kind of nutty. That's great, honestly. But anyway. Despite all of this compiler stuff, what are you doing on the game? Still fix the transaction system. The transaction system is mostly good. I was doing some animation work and I don't know, other stuff. I'm finding a lot of how did this ever work? No, this worked until this morning at the start of this stream when we broke it. This isn't a how did this ever work situation. This stuff that we did here is exactly causing the problem but that's fine. So really what we need to do is go turn back on the cycle breaking now, because, okay, so this thing is wrong. Here we only let people go if they pass the run pipe, okay? Now, this thing that I commented out for detect a cycle needs to be changed. Okay. So detect a cycle, this is the wrong detect a cycle. The one that takes a pipe, this one, pipes.cpp. Okay. This the reason this is flawed, it's doing a simply connected component detection, which is a graph algorithm that you learn in computer school, that I actually never learned in computer school, but other people do. And yeah, so basically though, it's using the old dependency system. And I need to make it use the new system. Okay, so here, instead of iterating over dependencies, we need you need to go over that new array that we made. This known callees thing. And the data structures are laid out a little bit different, but we do this. So we're going to have to check this, the is breakable dependency. Okay, that's fine. That is fine. Okay, so if we can pass, so let's just check. Let's check for dependencies. All right, so there aren't any till down here. So down here we have the body again, and we're going to go body known callees. Okay. If it's a breakable dependency, I'm just going to put a flag on this. Okay, so is breakable dependency target queued. And it's not, we don't need to check that. That's not a thing. And yeah, we're just going to do this. Okay, so cycle break. What the hell is that about? Well, we set that, and then we only care about this if cycle break is not set. Okay. Target queued is, oh, Kali, arrow, Kali, arrow queued. 1194, dep target. Why do I use C++ style cast over C style? Because I don't always do that, but A, there's some additional checking that is better. Like you can't, with a static cast, you can't cross cast something out of a struct hierarchy to another one, and that's good. But also, it's just, you see that there's a cast there. You can like search for casts, because casts can cause problems. Like to me, casts are a much bigger deal than just like putting something in parentheses, you know? Okay. Sokoban game. Now that's weird because it used to compile and now it doesn't for the same reasons. Oh. In our own, okay. There are several problems in what I just did. First problem. Remember that I'm leaving all the elements in the known callees array. So maybe I should take them out, but this should be known callees cursor and not 0. Like all of this. Let's call it Kali since we're not. Okay, second. If we did a cycle break, I don't think this is going to matter, but it might. All right. Didn't matter. So possibly, so we have assert, append, tprint, expand, print to builder. These guys are all probably in pipe run. Let's do this. Okay. I mean, this is a little weird. Let's just, so for debugging purposes, we're going to comment this out, and I want to run detect a cycle on, oh, you know what? That's not. All right. Oh, we don't even, oh. Bleh. All right. So, we're reporting a stuck pipe. Oh my God, the run pipe has so much stuff in it. This is going to be annoying. I was hoping, hold on. We just need a really small so let's go here. We could even go smaller than this if we need. Okay. Now, it's 75. That's still more than I would like. Let's just see if we can make heads or tails of this. If not, we'll do an even smaller program. Okay. So we're doing our simply connected components for 75 things. We Q sort it. Uh-oh, what's this? Forgot to look at this. Okay, that's fine. That should not have changed. What does our DFS do? Oh, wow, oh. We went to the duty-free store, but we did it wrong. We went to the wrong duty-free store. Okay. We went to the wrong duty-free store. So we're going to do that. Okay. The rest of that seems fine. You know what? I almost kind of want this in its own file, the cycle breaking stuff. Whoops, body. Right. Okay. Come on, you can compile. Thank you. All right, well, that didn't help. Like, not visibly, but it might have helped our diagnostic situation. Okay. 75 things still. All right, well, maybe we screwed that up. Okay. Run to cursor. DFS. Oh, let's also do the I don't think that's going to fix it, but you never know. You never know till you try. Okay. DFS. DFS. Okay, that's working. Wait, it's... I guess we don't assign anything. We just, I don't remember how this algorithm works. Aren't we supposed to be setting stack index here? Why are we not doing that? Oh, there it is. Okay. So I don't know what that does some things. All right. So we sort things, whoops. We sort things by stack in. Oh, come on, bro. I just hit the wrong button for a second. Okay. So group ID should be 0, right? Oh, 76. We go in the opposite order, I guess. So we grab start, 0, and 2. So we have 3 guys, or 2 guys, I guess. Okay, this pipe flag thing should go away. We don't need that. Did we lose chat? I'm not seeing chat anymore. Is it just followers only chat is very quiet? Test. Okay, it's quiet. That's fine. That is fine. Do subs count as followers for follower only chat? Or like what's going on there? I hope so. Like, you never know what policy decision they made there. Like, I don't want people to have to sub and follow. Okay. You can sub but not follow. Oh, that's silly. I don't usually follow on Twitch. Okay. So this pipe flag thing shouldn't matter. Whoops. Okay. I mean, at this point, like visualizing this algorithm is like, oh my God, right? Line 248 of array, right? So that's going to call array reserve. Which is going to call realloc. Which is going to call allocator. Okay. I should actually stop and think about this algorithm sometime and re-understand it thoroughly, but I don't want to do that right now because it'd be boring on the stream. Boring on the stream. Okay. Let's Okay. So let's go to group ID 0. We should be able to get there. Okay. So let's take that out. Okay. Start 30 and 75. Okay. Group ID, maybe that was a mistake. Group ID 0 has a lot of dudes in it. All right. So let's just start looking at what happens. Cursor 0, call these items 1. Oh. Uh-oh. Wait, this is breakable dependency. Oh, this is whether everything in the cycle can pass, right? That's going to be not true for one of these guys. Line 9 of simple string. 2 string. Okay, this procedure is not polymorphic. Is not, I mean, it's nothing. There's nothing here. What is going on? Okay, so target. This is like approximately the simplest procedure that you could have. It only uses built-in types. It's not polymorphic. It doesn't call anybody else. It doesn't use the context. Oh, it calls assert. Never mind. So it's assert. Assert is not right. So just like this. Okay, here's what we want to do. We want to print out for a minute this group ID. So we're going to go no check-in, print, actually, group ID is %d, and it's node queued stack index. This will be left over from whatever the previous, whoops, we need not printf, from whatever the previous thinger was. All right. So there we go. Group ID 75. Okay. So now we can go to that group ID in the cycle break and see why it's not breaking. As long as we are running this, or we're running this with no jobs, let's do that. Okay, it's still 75. So, here, where were we? I forget where this was. Prints, not print site. Ugh. And explain. Where is it? Where was the thing that we just did that was like break? So we had a thing. Oh, it's not here. Haha. Wait. Why can I not remember what file? It's in pump. Detect a cycle. Right there. This is what I was looking for. That's what I was looking for. Took a minute. See you later, man. Report stuck pipe. All right. So, oh, we have a breakpoint there. Great. Great. Okay, we don't want these breakpoints right now. These are not the thing. We do want this. Okay, so now we go to here and we want group 75. Okay, so we want group ID is 75, and there should be like 5 things in it, right? There should be 1, 2, 3, 4, 5. So run to cursor, start 24, end 26. That's weird. Why is it different? Oh, am I printing the wrong things? No. As far as I can tell, I am not. So that's weird. That's weird. I'm not sure what's going on there. Let's just take a look at what these are, though. Simple string, line 9. To string. Why is that? Wait, did we do this right? Frickin' program. Oh, okay. So Visual Studio gets worse and worse. Okay, I put this breakpoint on the line where this is defined, and it like silently fails to do the condition correctly. We might have passed what we wanted. Anyway. Okay, yeah. Yeah, yeah. So we want to disable this for now. Go into here, re-enable it. And go. Okay. Now, line 176 of print. Okay, that sounds good. And start to end 24. Oh, that's a lot. Anyway, print has a callee. That's fine. Why are there so many people? Oh, okay. Why are there so many people in this group? I thought it was supposed to be small. We're in 75, right? Group ID 75. Who can't pass? Well, line 176 of print. Print float, that's kind of complicated, sure. And target. Oh God. STB sprintf. This is foreign. It doesn't have a body, bro. Or it has one, but it doesn't. Okay. Why are we jamming on that? Okay. Remember when I said I'm just going to keep all these items in this array, okay? And like we're just going to keep it there for debugging and it's fine. That is not good, okay? The reason that is not good is confusing the cycle detector because we're just stopping this cursor at the point where we hit our first problem. But the cycle detector is seeing everybody in the array after that, even though most of those things are clear. They should have been cleared, but they're not. So we're detecting phantom cycles that are not a problem. Jump into conclusions. Are there any questions that people have about, like, on-topic questions? That people have about what is specifically going on here? We're going to maybe break for lunch soon, but I think we may be able to fix this. Is this issue because of threading? No, this has nothing to do with threading at all. This is just nonlinear compilation. No other questions? Okay. Well, let's try to fix this. We done made a mistake. Okay, so here we just say continue. Otherwise, we remove guys from known callees. Okay, down here, there. So now we have all these things who want the callee cursor that we put in. Oh, it's called callee's cursor. This is going to go back to 0 for now, and we might change the loop format later. It's going to go 0. 0, because there is no known callee's cursor anymore. See if other people are still trying to use it. Convert from all right, we'll do this by value. God, this editor sucks. There we go. Now there's a raid. What's going on, raid people? There's a raid in the shade. Everybody now has to go watch the movie The Raid because there's a raid. Don't the warnings annoy me a little bit? Yeah. Hey, we compiled that program. Hey, we compiled that program. So we're back to this point. So can we compile this program? Looking good. Looking good. Come on. Come on. It's slow. It takes about 14 seconds. Yeah, with the debug compiler. There we go. That is the high water mark of today. I could have saved over an hour of debugging time if I had only done it that way from the beginning. Simple mistake. It's just what happens when systems are complex and you're not thinking of all the relevant pieces in the right way. Just programs are complicated. And play Raid Shadow Legends. I don't know what game that is. I will say the movie The Raid is a very good movie. So I made Daniel Benmergui watch it when he was here last year. Nice shirt. Thank you. What is the reason for nonlinear compilation? It is that you don't have to have header files or order of declaration. Looks like we're doing okay. Okay. So what's going to happen is we're going to check this in. I'm going to break for lunch and stuff. We'll come back and do another stream where we have a code deletion festival. Actually, first we need to fix this. We'll fix this because that's important. And then we'll have a code deletion festival. And then I'll be so happy. Oh my God. Another stream. Yeah, I'm just in a streaming mood. What will come out first, Sokoban or the compiler? Probably the compiler. But that's not a guarantee, but probably. All right, everybody. Thanks for coming by. Let's see if there's a friend to raid with the raid on twitch.tv. Oh, we could do Handmade Hero. Let's do that. We haven't raided Handmade Hero in a little bit. We just raided Lana like a minute ago. All right, we're going to raid Handmade Hero. Thanks for coming by, and I'll see you later. It's almost over. Well, then he can pass the raid on. Devin raided us when we were almost over.